Okay, good evening, ladies and gentlemen. This is Professor David J. Delosreyes. What will I will be discussing tonight will be the concept on how an induction stove operates. So I opened the case of an induction stove, and as you can see it, these are just the internal parts. Okay. The internal parts are actually, this is the so-called induction coil. This is the main power supply. It got some toroid, what do you call this, transformers over here needed for the power supply. We got some relays over here. And after the power supply, the other part is actually the control board. This is the control board. This control board, there is a plug-in thing over here. And the plug-in thing is this one. Excuse me. That's where the button of the induction stove. Okay, we needed this one to push some buttons to operate the induction stove. Okay, I will try to place it up. So I will go back to the inside of the induction stove. Like what I said, this is the induction coil. This is the power supply. This is the control circuit board. Okay, including this one. So this one here is plugged in over here. And we got an electric fan over here to cool off the inside of the induction stove. And how does an induction stove operates? In induction stove, there is no such thing as what you call this fire to heat up a food. What will heat up the food is that once we energize the control board, okay, there will be an applied voltage here on the induction coil. A direct current will be circulating over here, okay, and once a direct current is applied over here, coming from the control circuit board, okay, this induction coil will try to come out or came out with what they call this a magnetic thing. Once this coil is energized, there will be a magnetism that will be produced. And that magnetism actually, that's the one heating up our food. And how does it do it? The bottom portion of the cooking fat, this one here, that's not an aluminum thing. It's a ferrous thing. It's an iron. Because induction stove, okay, if you try to use an aluminum, it will not work. It should be an iron. This thick part here is an iron. So for stainless steel cooking fat, of course the sidings is stainless, but the bottom portion, for us to use this using the induction stove, this should be metal made of iron. The inside of this one is iron. It is just plated with a little bit of stainless. But the main component of this thick thing here is actually an iron. So the requirement for induction stove is that the bottom portion of the cooking fat should be an iron. Why is it an iron? Because an iron, once a magnetism will try to penetrate it, it offers too much resistance to that magnetism produced by the induction coil. It offers too much resistance. And under the study of circuitry, if a resistance is big, of course there will be a current equivalent to it. Okay? So a ferrous thing under the cooking pot is a good resistance for this magnetic thing that will be happening over here. So actually, the one cooking our food is just the magnetic thing produced by the induction coil, because the induction coil was energized by a direct current voltage. For as long as the direct current voltage is circulating over here, the magnetism that it will produce, okay, interacts with the bottom portion of the cooking fat, and as it penetrates the bottom portion of the cooking pot, which is made of iron, which offers so much resistance, so supposed to be there will be a current passing through it, okay, passing through it, which will heat up the bottom portion of the cooking pot. This bottom portion will be heat up due to the magnetism produced by the induction coil. So induction stove actually doesn't produce any fire. It will just heat up the bottom portion of the cooking pot using magnetism. So for as long as that magnetism is present, the bottom portion will be hot. And since the bottom portion will be hot, of course, anything that you put inside will be cooked. If you are trying to heat up some water, okay, it will heat up the water. If you're trying to cook some food, of course, there is a water portion of that food. And as soon as that water heats up, of course, the food that we will be cooking will be cooked. So I just want to emphasize that induction stove cooks our food by using magnetism produced by the induction coil. There is no fire. So actually, the top portion, this portion here, this is where we will place the cooking fat. While you are cooking, you are not seeing any fire on the bottom. Unlike on the ordinary electric stove, there is a fire. But for induction stove, the one that heats up the bottom is actually the magnetism produced by the so-called induction coil. Okay? I will repeat it. The one that will cook our food is actually the magnetism produced by this induction coil, because once this induction coil, if we try to pass a current here, there will be a large volume of magnetism that will appear here, and this magnetism interacts with the bottom of the cooking pot. And for good interaction of that magnetism with the bottom of the magnetic pot, the bottom of the magnetic pot should be made of iron. Okay? If you try to use aluminum, it will not work. The bottom portion should be a ferrous thing, an iron thing, right? Okay? This is made of iron. It is just plated with aluminum, but the internal part is actually iron. That's why if you try to put your stainless steel pot, the bottom portion is very thick. That bottom portion is actually made of iron. It is just plated with a little bit of aluminum. So the requirement for an induction stove for it to generate heat much faster due to the magnetism produced by the induction coil, the cooking fat should be, the bottom portion should be made of iron. Okay? Oh, that's how the induction stove operates. So bear in mind that induction stove doesn't produce a fire, right? The one that will cook our food will be the magnetism produced by the induction coil, because the induction coil was energized by a direct current voltage coming from the control circuit. Of course, the control circuit is powered by the power supply. So the requirement is that you should have a good power supply, and this power supply, okay, apply voltage to the control circuit. That's why there is a low voltage transformer over here. The output of this one should be maybe 12 volts, something like that. And 12 volts is actually good for a control circuit, Because if we could not produce a 12 volt on the secondary of the transformer on the control board, okay, the requirements for these ICs here, these are the parts of the control board. The requirements for this one are DC voltages, okay. So the voltage coming from the main power supply, it will be applied to this step-down transformer, and the output of this one should be a voltage outputs maybe in the range 12 volts, because the voltages needed by these ICs here are actually 12 volts or 15 volts or 9 volts. It depends on what are the specifications. Because some of the internal parts of the control board, it got a resistor here, it got some transistors, got 3 ICs, okay, and these are all interconnected to energize the induction coil. This is where the entry point of that voltage coming from the control board, and that will be the one that will try to energize this coil here. And like what I said, once this coil here is energized, okay, there will be a magnetism produced due to the introduction of the current passing through this coil here. And that magnetism interacts with the bottom portion of the coking fat we are using. And once it interacts, it will heat up the bottom, and of course, it will cook our food. And bear in mind that there is no fire produced in using an induction stove. The one that will cook our food is actually the magnetism produced by the induction coil. And that's it, guys. That's the internal parts of an induction stove and how an induction stove operates. Good evening from Los Angeles. This is Professor David J. De Los Reyes.